Hello everyone, my name's Jim Shipley. I'm the Manager for Business Development at Quintus Technologies. And today I'm sitting here with Magnus from VBN Components. Magnus, can you introduce yourself a little bit and tell us about VBN?
Yeah, hi Jim, great to be here. My name is Magnus Bergman and I'm CEO for VBN Components, based in Uppsala in Sweden.
Right, and what do VBN do? I mean, I guess lots of companies maybe have heard about VBN, they've seen you at some shows, they've seen you around the world, and they maybe heard about your branded Vibenite materials. But I mean, tell us a little bit about VBN Components.
Yeah, VBN Components is specialized in developing wear-resistant hard metals using AM technology.
Right.
And to produce hard components, and we do that for many different industries and applications.
Right. Okay. Yeah. So I mean, so these kind of hard materials. I mean, everybody knows about Vibenite. I guess maybe they don't. But tell us. I mean, Vibenite materials. What's so special about this?
Yeah, Vibenite is a range of materials that are high-speed steels and hard metals, focused on the hardness and wear resistance, and all developed for using AM technology to produce components.
Right, and I mean, how hard are these materials compared with what's available on the market from others in terms of wear-resistant tool steel materials?
We have now managed to get the hardness for Vibenite 290 up to 75 Rockwell C.
Wow.
Thanks to also the material itself, but also the process and the improved hip and hardening process. And of course, that is compared with a conventional high-speed steel where you can reach maybe 60 or 67 Rockwell. It's quite a hard material.
Right. So I mean, so VBN as a company, would you describe yourself as a 3D printing company or as a material developer, or where do you fit into?
I prefer to say that we are a materials development company using additive manufacturing technology to print the really hard materials.
Right.
And we have a very long, strong expertise in the fields of material science, powder metallurgy, tribology, additive manufacturing, and also in the field of thermal processing of these materials.
Right, so you have in-house metallurgists developing the materials and everything else.
Yeah. So this gives us a quite unique position in developing and these areas.
So let's move on now and talk a little bit about applications for Vibenite and for your technologies. So I mean, most of the AM industry is really focused on aerospace, space, medical. Where's your niche? What are you supplying your materials to?
Yeah, I agree, Jim. That's where the focus is for the others. We focus mainly on applications outside that area for all kinds of diverse industries. With our properties, we can address expectations in many different industrial applications.
Right. Can you give us some examples?
Yeah, just some examples. For obvious reasons, I cannot show our customers' actual designs for confidentiality reasons, but I have some more generic examples here. Starting with this small part, it's a nozzle for sandblasting. That is very, of course, wear resistant in our materials, and you can produce quite relatively complex shapes that would be difficult to produce with conventional methods.
So you're extending the longevity of the part then, basically,
exactly,
before it wears out.
Yeah.
Okay, nice.
And here we have a pretty big item, which is a little bit showing the possibilities in tooling, where you can 3D print blanks in our material, and you can also include things like lightweight net structures to reduce the weight of the. So
you have using electron beam powder bed fusion, you can actually do all of the complex structures that AM enables, and with a very hard material.
Yeah, exactly.
Right. Okay.
That's a big advantage, and I mean, it's always a case of using both the properties of the material and the possibilities and the design freedom of 3D printing.
So like I can see here that you're adding in like cooling channels or channels for liquids to go through or whatever. So you can do all of that in the complex structure.
Exactly. Yeah. And that is something that would be probably impossible to do with any other conventional method.
Right. Very nice. Yeah. So what other kind of industries are you involved in?
This is interesting also, process industry.
Yeah.
separator part that is quite complex, as you can see. A lot of small holes and channels and so on that I think would be more or less impossible to do in another way. But here you can 3D print it quite easily in a very hard wear-resistant material to give a long life of this product.
And I guess, without putting you on the spot now, I mean, the delivery time to actually design and make one of these for customers must be a lot shorter than traditional routes to make this kind of part.
Yes, exactly. I mean, after that we have designed this part, I mean, within 2 weeks you can have a number of these on your desk ready to use.
Right.
So it's a very quick process and very short lead times.
Excellent.
And we have some other parts here also showing for bearings, for example. Also showing, here's a case where our fatigue properties are very important as well, not only the wear properties.
And their hip helps, of course.
Of course, it does. Yeah. And basically, we use hipping for all of these components.
Yeah. Is this kind of for the paper industry, for debarking and things like that?
No, this is actually for a tool for making gears.
Gears?
It's a hob. It's a small hob.
Okay. Yeah.
For relatively small gears.
Okay.
So this is printed, then it will be ground and coated before it can be used, but this is in printed and heat-treated state.
Oh, nice. Yeah.
And here, of course, is a good example of where the absence of pores or impurities is crucial.
Right.
We cannot have anything in these small teeth that would risk crack initiation. So that you have to have both a good printing process and the hip process and heat treatment afterwards to ensure that you have a fully pore-free material.
Very nice. And this is some kind of blade?
Yeah, this is actually a cutting knife. This one cuts cheese doodles.
Cheese doodles?
Yeah.
Oh, nice application.
Yeah, and maybe you wouldn't think that, but the cheese doodle paste is very erosive.
Okay.
So it is crucial to have a knife with a good wear resistance.
Okay.
So we are in diverse industries.
Very interesting, very interesting. So for the hardness of these materials compared with other materials on the market, I mean, you've developed these specific powders and specific material combinations. I mean, how do you make those available to your customers?
How we normally work with a customer is that we start a discussion, of course, with them, and we offer something we call a pre-study. And a pre-study includes, of course, a lot of discussions about what material to use and any possibilities for design improvements and so on. But also that we do produce a couple of, could be 1, could be 5, could be 10 prototypes, so that the customer couldn't really test it in their application to see that it meets their expectations. That is the normal start of a cooperation. And then, of course, after that, we go into maybe further improvement of the design and series production. And it could be a series production starting in our facility, but the end goal is normally that the customer would have their own equipment and do the production in-house with our support.
Okay. Yeah. So when it comes to heat treatment of these parts, obviously heat treatment of these kind of hard materials is critical. What's it all about?
Yeah, as you say, heat treatment of these parts or of metals is crucial. You need heat treatment. A steel without heat treatment is useless. But on the same time, they are sensitive to heat treatment history and thermal history and cooling speeds and so on. So we have developed very precise processes for the heat treatment. So after the printing, we would hip the material and harden and temper according to very specific processes.
Okay, and if you didn't do the hipping, what would the difference be?
We would see that the toughness of the material would be lower at the same hardness, and there will be a bigger risk of failure.
Right.
So it's a little bit of a statistical risk. So we sometimes say that the hip is an insurance against any potential failures.
Right. And I guess those failures can be quite catastrophic and quite expensive. I mean, what's the cost like when we're looking at doing it this way compared with a traditional route for wear materials?
Yeah, I mean, what we offer with our process is a quite high productivity in our printing and the process in general. So because we are aiming at industries where cost is an important factor. So we have high productivity, we print at relatively high build speeds and so on. But you also have to look at the complete picture, the bigger picture of the cost. I mean, what you save in terms of reduced stock, reduced transportation, reduced use of material and energy in the production. And also the longevity of the component. And maybe you can even run your equipment, your process at a higher speed because you have a better product, harder, more wear-resistant material. And also that, of course, the advantages in terms of green advantages, so that we have a less use of material and energy, you have less transportation and so on. So there are a number of values there that you can see based on both the material and on the AM process.
Right. I mean, sustainability is always one of these things that's brought up by additive manufacturing companies on, using less materials and things like this. I guess the longevity of these parts in service, it must be a huge sustainability advantage for customers.
Exactly, it is.
Yeah.
It's both a pure cost advantage, of course, but also sustainability advantage. Because these are parts that could be difficult to change also, so it's a very important factor. But also we should not forget about lead times, for example. A very common requirement from our customers that they see the advantage in reduced lead times.
Right. So yeah, I mean, there are obviously lots of benefits, but I mean, what makes VBN special compared with other companies working with these kind of materials? Yeah,
what is unique is that we can really produce crack-free, hard materials for 3D printing. So we can make components on these kind of materials without the risks of cracking. And that is unique. And of course, we have a lot of know-how to offer, knowledge and support to the customers. And I would like to emphasize this possibility for the customer to, when they go through this pre-study, they can, without any big initial investment in time or resources, they can get started using AM components by having prototypes printed, tested, and supported by us.
All right. Yeah, I mean, so the cooperation, obviously, with Quintus, we're on a Quintus Tech Talk here. You're working with us, you have one of our HIPs. I mean, why work with us? Why are you sitting here today?
Yeah, I mean, we've seen that, of course, Quintus has a very advanced equipment and the process around it, everything. So the equipment itself, combined with the technical support and the knowledge, is what we were looking for and what we appreciate. We've also seen that Quintus Technologies has a big focus on additive manufacturing, which is good for us. So we have someone to discuss and partner up with when it comes to additive manufacturing issues or topics specifically.
And of course, we love talking about metallurgy. So there's a win-win there.
Exactly.
Yeah. So the HIP that you've got in-house now, I mean, what difference does that make?
Yeah, I mean, partnering up with Quintus and acquiring and getting our own in-house capabilities for HIP and heat treatment has given us a strong competitive advantage. We have seen that our lead times, before we used to buy the HIP and heat treatment services from the outside, and then we had the lead times from powder to finished product of 6 to 8 weeks. And now with our in-house capabilities, we can reduce that to 1 or 2 weeks, which is a great competitive advantage.
Yeah, and the HIP you have has also the quenching function.
Exactly.
Because of these kind of materials. Right?
Exactly. We have the HIP with the URQ technology. And the URQ technology, of course, provides a very rapid cooling. And that is perfect for our materials. by having our own in-house equipment, both the HIP and the heat treatment, we can really optimize the parameters for our needs and for the customer, the client's specific applications. So we can develop and we can specialize the heat treatment for specific applications in a way we could not do with a subcontractor in the same way.
Okay, all right, good. So going forward, where do you see the relationship going with Quintus now as you expand and become a larger company?
Yeah, I think that partnering up with Quintus also for the future will mean that we will have access to a partner who we can discuss these things with, how to improve the process, how to optimize it for our specific needs. We are going to expand into new industries, new applications, and develop new materials, and there will be a constant need for development in terms of HIP and heat treatment processes as well. And we have realized that to be a leader in AM technology, you have to master also the post-processing. Right. It's a very crucial part.
And of course, you're very close to us in terms of geography, but also you're very close to our application team in the application center here in Västerås.
Yeah.
And I know that we've done a lot of development work together. I guess that will continue as well with the new alloys that are coming and new processes?
It definitely will. We like to have someone to discuss these matters with, and that is a crucial part of our partnership, definitely.
So I guess your in-house team, obviously you never hipped before, so it's like you're learning to do a new process and learning how to use the equipment, and you feel like you're getting the support you need from us.
Yes, yeah.
Great.
That's correct, and yes, you're right. We didn't have any experience of hipping ourselves prior to acquiring the machine. Now, maybe this, I would just mention that, the 𝙒𝙖𝙗𝙦 rapid cooling, we achieve more than 2,000 degrees cooling rate is extremely fast and important for our types of materials.
Yeah. And of course, we're also interested to get feedback on what's needed going forward with machine developments and size of parts. Do you think things are going to get bigger, or do you think things are going to stay small, or what's your feeling?
Well, the fact today is that we have the size of the HIP and heat treatment equipment is the same as the size of our printing machines.
Right.
So for if we print, we don't need a bigger machine today.
Right.
But on the same time, the size of the printers are getting bigger.
Right.
So if we in the future will have bigger machines than for printing, we would need bigger machines for hipping
of course,
as well.
Of course, we have larger 𝙒𝙗 machines as well,
yeah,
so that's not a problem. Okay. So Magnus, your unique products, these are Vibenite alloys, the family of alloys. Obviously, you're helping people get going with the production, the prototyping, and selling initial parts to a company, and hopefully they'll, as you mentioned, produce their own parts in-house. What about the powders? Do you sell powder and anybody can buy it, or how do you work?
Yeah, we don't sell powder just like that as a powder supplier. We see ourselves as a supplier of the material and the process and the IP surrounding it. So what we do is that we sign license agreements with our customers who can then buy the powder, and they get access to our technology and our IP as well.
Right.
So that's the way we work. We're not just a powder supplier.
Right. Yeah. So you're actually helping the customers get going with their process, and then enabling them to continue production and ramp up.
Exactly. That's correct. Yeah.
Okay. So to round things off, Magnus, where can our viewers find more information about VBN Components?
Yeah, I would like them to take contact with me or my colleagues, and you can do that through our website, vbncomponents.com, where you can find the information and the contact details. And we can also recommend reading the white paper that we have written together with Quintus. on these topics.
Right, yeah, and that was presented, I think, a couple of years ago at PowderMet in the US. And it's also available on our website in the Knowledge Center there, where most of our other information can be found as well. So that's really good. Well, and I'd like to thank our viewers for checking in today and listening to this discussion. I hope you learned something good. And Magnus, thanks a lot for coming in, and wishing you all the best in the future with your efforts.
Thank you, Jim. It's been a pleasure.